Welcome to muscle damage part 2. In part 1, we basically talked about, hey, this is what it is, this is what causes it. But there are a lot of repercussions to damage, and so there are interventions that we need to understand. Speaking of those repercussions, several sports require multiple bouts of high-intensity exercise with little recovery. We have a pitcher has several high velocity eccentric contractions. Right, and a pitcher might have a few days off, but if you're a reliever, particularly like in the playoffs, you may have to pitch several games straight. Other sports like hockey require several bouts of high intensity sprints, and athletes have to play several games per week. Clearly, this will impair performance. In fact, one of the biggest things we see is percentage decline or percentage of maximal output in strength as well as in power. So what you can see is that both strength and power have decrements, and that those decrements can be down 3 days after exercise. It may take 7 days after exercise. The other thing is that if you have a new client who's untrained and extremely damaged and sore the next day, they might quit and not adhere to the program. Also, muscle damage can impair performance on two-a-days during preseason. If you look at strength in people especially in people who are untrained or coming off from a long off season, you may decrease the size of the muscle for up to 56 days before it's actually recovered. So extreme damage you have to be very careful with. In fact, we see in this thing that percent initial values of MVC may be depressed for even 80 days, 90 days following the initial bout. However, one thing to point out is we do get a repeated bout effect. So if you look, this is a real simple study that we did. If you look at S1, we did curl exercises in untrained people. You look at VAS, which is visual analog scale soreness, went up in session 1. We brought them back for session 2. They weren't sore at all. And the same thing happened with creatine kinase. So you can develop a repeated bout effect, which is some sort of protective effects against the muscle. We think it occurs by the addition of remodeling existing sarcomeres, addition of new strong sarcomeres as well. And this is how it works. If you have two sarcomeres, for any given distance, they're stretched more than on the bottom when you have three sarcomeres. So how can we apply our knowledge of the repeated bout effect? This is a study. If you look at the arrow all the way on the bottom, you're looking at muscle damage as indicated by creatine kinase values. So the first group that's on the bottom, this is the first 7 days, they actually perform one set of 10 reps. If you notice, it was high intensity, or moderately high intensity. They had no measurable muscle damage. The arrow at the top is pointing to the two groups that perform either 3 sets of 10 or 5 sets of 10. Notice they had quite robust increases in muscle damage. They came back 7 days later, and all of them did 3 sets of 10, and none of them increased markedly in muscle damage. This suggests that if with high-intensity exercise, you can create a protective effect against muscle, even if the volume is low. That's what we see here. So, how important is intensity for the repeated bout effect? Obviously volume is important, but it doesn't seem to be as important, but intensity is. So in 2005, Chen examined the effects of training at 40, 60, 80, and 100% of isometric MVC using eccentric only contractions on the repeated bout effect that was performed at 100% maximal voluntary contraction. So they performed the initial exercise bout, and what I want you to look at over to the left of the screen, you're looking at bout 1, eccentric bout 1. You're looking at declines and maximal strength. Okay? The yellow group highlighted represents 80 and 100% of the maximal output, maximal 1RM. Notice that their maximal isometric strength went down the most. However, the 40 and 60% went down the least. This makes perfect sense. When you come back 7 days later to look at the repeated bout effect, you notice that when you do the activity at 100% of your max, that the 80 and 100% group, which is the yellow group, actually had the greatest protective effect. So the 40% only partially protects you. So it's a small 20 to 60% protection effect, whereas the 80% has a much larger effect. If you go over to change in circumference, which is a measure of edema, notice that the yellow group has the greatest edema, about 1, compared to the green, which again is the low intensity groups. But it actually reverses the following weeks. Then if you look at creatine kinase, you see that week 1, the yellow group, which is the high intensity, 80 to 100%, have notably high levels of CK, whereas the green group have low. But you come back and you expose them all to 100% 1RM stimulus, and that switches. The green has the most damage compared to the yellow. So what's the take-home message on this? Well, basically, lighter weight provides only a partial protection, whereas high-intensity exercise provides much larger, robust protection. So one thing to point out is that the length of contraction is required for repeated bout effect. So you're looking basically at the left side graph. You see bout 1. And if you look at bout 1, you're looking at declines in maximal voluntary contraction. And this is fully lengthened contraction. Notice that performance drops the most at bout 1 there. If you look at bout 2, which are the open circles, you see more of a repeated bout effect. It has a protective mechanism. And if you go over to your right and you look at the shortening to lengthening contractions, or the shorter lengths, and then moving to a lengthened contraction, basically you start off the first week, shortened contractions only cause a slight decline, whereas when you switch to a longer contraction, you see it doesn't provide a full protective effect. So the main point is this: shorter lengths only provide half of the protective effect as longer lengths. This is a pretty interesting picture here. You're looking at declines in peak torque after a damaging exercise. You notice that the arms, which are the black squares, drop more than the legs, which are the black diamonds. This is probably because the legs are exposed to walking and moving each day, while the arms are used minimally. Now, what about the transfer from one exercise to another? We did a study where we had people perform incline curls or preacher curls on day 1. Now, what you're looking at is muscle soreness on day 1, and that's the yellow highlight. You can see that they had a lot of damage. But you bring them back week 2, and regardless of what exercise they switched to, they had much lower muscle damage. So this is suggesting that with similar exercises, like the incline curl and preacher curl, you should get a transfer of the repeated bout effect. Now, Eston found that 100 maximal isokinetic eccentric contractions also lowered muscle damage on downhill running. So what you're seeing essentially here, that is the group that did downhill running after doing the 100 isometric eccentric contractions, and the other group is when you did not perform that. So after you have developed the repeated bout effect, it should transfer. So how long does the repeated bout effect occur? That's the question. Well, if you look at, basically what we're looking at is creatine kinase levels to the right. And if you look at baseline muscle damage, and then you train again 2 weeks later here, much lower creatine kinase. But if you wait at 36 weeks, much higher creatine kinase, with 52 weeks being fully no longer protected. The point is that the protective effects you get with repeated bout effect are only 2 to 4 weeks in range, so you should train within that time if you want to keep those effects. So let's do practical applications. If you have little or no training experience, start with low volume, like 1 to 2 sets per body part, single exercise, low intensity exercise. That will start a protective effect happening. 2, progress to low volume, single exercise, high intensity exercise. 3, progress to multiple single exercise, high intensity exercise. And finally, progress to multiple exercise, high intensity exercise. If you do that, you'll have a repeated bout effect with all of your training sessions, and you'll be able to sort of work your way up without losing sarcomeres. If you're an athlete and you're moving from the off-season to in-season or to preseason, I would advise athletes prior to coming to practice to perform a low-volume, high-intensity weight training session at least 1 to 2 weeks prior to the season. That'll protect at least a repeated bout effect that should transfer. During week 1, I do high-intensity exercise that's limited in its volume. So you're just trying to create a protective effect. You're not trying to cause extreme volume changes. Also, week 1, I focus on getting the rhythm of the athletes back without causing severe damage. And finally, weeks 2 to 3, now that you can progress to higher volume, high intensity work, go do it. Now, as far as power athletes, if you look basically at power, you can see powers in the black. You see power immediately post, day 1, day 2, and day 3, it's still impaired, right? So, again, if you're a pitcher and you're pitching 2 days later, that's a problem. Your power output's down. One thing, though, is that under damaging conditions, athletes can overcome damage by using counter movements. So what you're seeing here is a squat jump, and a squat jump, essentially, you squat down, no momentum, and jump straight up. A counter movement jump, obviously, you start standing, counter down, and jump up. Notice that power percentage of 1RM is higher when you do a counter movement compared to a squat jump. So this suggests that maybe athletes can use the stretch shorten cycle to overcome muscle damage. But to do that, you may need to practice working with the stretch shorten cycle more, and plyometrics is good for that. So now we're going to talk about is endurance athletes. Endurance athletes, actually, when you have muscle damage, their blood lactate is actually higher, which is the open circle, than the dark circle. As far as different warm-up modalities, this study shows that warming up does not prevent muscle damage. However, I'm not saying it's not important to warm up. Warming up can be important for performance, but it's not going to lower muscle damage. Okay, so what this is looking at is, does active recovery speed recovery from damage? So if you pre is a dark, post is a striped. So you're looking at as muscle soreness. So you go day 1, they're pretty sore, 40 millimeters. But after you warm up and do some essentially active recovery, the soreness goes down temporarily. You can notice that post. When you come back to day 2, the soreness is right back up. Same thing happens with day 3. So basically what we think is that athletes can use light exercise before competition when they are damaged from analgesic effect, but not to speed recovery. Now, light concentric exercise does not have an effect on recovery of strength or range of motion either. And that's what we're seeing here. In other words, active recovery may not be necessary for recovery. Now, does stretching before decrease damage? The answer is no. As you can see in this slide, you look at strength loss when you stretch before or didn't stretch at all. Strength loss is actually lower when you stretch. That's it. Check out your questions. If you have any other questions, I'll see you in class.